Problem 3. At each integer on the number line from 0 through 2022, a person is standing at the start of a process. In each move, two of these people standing at least 2 points apart are chosen. Each of these walks 1 unit closer to the other. If no further move is possible, the process ends. Prove that this process must terminate after a finite number of moves and determine all possible final configurations where the persons can stand. The configuration only take into account how many persons stand at each number. This task was presented by Birgit Vera Schmidt. Okay, so let us start. First of all, let us kind of have a feeling of how does it work. Let's draw a line not 0 through 2022. We cannot do it, but let us start with 0, 1, 2, 3, 4, 5. And then let us code it through 1, 1, 1, 1, 1. And let us continue moving to see how it goes. We can start with marginal points. For example, these ones. I don't really get what is at least 2 units apart. What is a unit really? Is it a dot or is it an interval? But let us consider that 2 units means 2 intervals. So this one moves. It becomes, then if we move like first to the second and third to the second, it becomes 0, first of all 2, but this also moves, so 0, 3, 0, 1, 1. The next line becomes, probably we move this and this, 0, 2, 1, 2, 0. And then this and this, 0, 1, 3, 1, 0. And then finally left and rightmost. So 0, 0, 5, 0, 0. So what do we see? It all converges, and it all converges to the center. Probably this is the best possible pattern that we should try to see in the other task. So how do we see it? We should seek to find the invariant. And the invariant is the sum of the elements. How many are there? If we arrange it to be something that doesn't change. So from 0 to 2022, it is the sum of 0 plus 1 plus 2 plus and so on plus 2022. Just like here, what works? Sum 0 from 1 plus 2 plus 3 plus 4. This is the sum of the elements in its positions. But if we consider this invariant further, it is probably going to a bit to nowhere. So how do we approach this problem? We need to think a little bit more of this. So let's strike it away. So first of all, what we need to do, if no further move is possible, the process ends. So how does it end? It ends, it appears that everything converges to the middle. So if we have infinitely many steps, and we have like many points, we have some set here, assuming that, as we see sooner or later, the leftmost and rightmost will move towards the middle. But let us consider the opposite, that for some reason left and right do not move towards the middle. It means that after infinite number of steps, all the rest will converge to the middle, and then we will have to move the left and rightmost dots anyway. But otherwise, we should assume, for if we don't want that to happen, that all the middle points can move infinitely without converging towards the final point, or at least some points after which no movement will be possible. Therefore, if that is possible, that this set has infinite movement, then there is next, like this of this subset, then there is second leftmost and second rightmost points that don't move, and all the other points do move towards the center. So in the subset of left and rightmost, we have to, if we assume that left and rightmost points don't move, then everything in the middle moves forever. And if it moves forever, then we must assume that left and right points do not converge towards the center. Because if they start converging, they sooner or later converge towards the center. So then we choose a subset. Among the subset, we have to again choose the subset for which can be infinitely moving, but left and right points don't move. And so we keep going like this forever until all 2022 points divided by 2 basically converge. So this is impossible, and therefore that after finite number of moves, no further moves will be possible, since left and right most points converge towards the center. Okay, now we are asked to determine all. So we did point 1, this one, and now we are starting number 2. Determine all possible final configurations where the persons can stand. So how does it work? From this one, it appears that this all goes towards the center. So what I think, I come from physics, therefore what can I say? I kind of think of it, why can it go towards the center? If we consider the balancing leverage, then we have 1 point here, 1 point here, 1 point here, and 1 point here. So let's say this line has no weight, and this is very durable. So we have this point mg and this point mg, and so like this distance is 1 and this distance is 2, and the same goes with the opposite side. And so we have the rule of moments, which is moments turning to the right equal moments turning clockwise, it should equal to the total moment turning anti-clockwise. So total moment turning clockwise, mg times 1 plus mg equals times 2 should equal to, guess what, a moment anti-clockwise. So again the same, this mg and this 1 times this plus this mg and this 2, mg times 1 plus mg times 2. Yeah, obviously this is a trivial statement. Yeah, mg can be reduced since all g is the same, and the masses of all the particles we can think of the same one. So here, what do we have here? This works for the first position. For the second position, we have 3 here. So 3mg times 1. This is the moment to the left, and the moment to the right, mg times 1 plus mg times 2, which gives us the same, mg times 3. So basically, and then here it's also the moment to the left and moment to the right. So this stick never falls neither to the left nor to the right. Let's give some more formal kind of proof of this. So if we are on the stick, I'll draw it in the middle. We have many points. So if many points. So if there are 2 points both to the right, so one moves, they converge to some point, so one point moves to the right and its moment increases by 1 mg, and the one moves left, its moment decreases by 1 mg. So each one-sided change of particles from one side to the center does not change the configuration of the stick. It doesn't make it fall neither to the left nor to the right. If this happens to the right side, the same would happen to the left side. But if for some reason, we should also consider the case when the balls go to the other side of the center. If this happens, for example, this ball goes to the right 2 positions, and this ball goes to the right 2 positions in 2 consecutive steps, for example, then we should consider that basically, and let us paint initially all this one as green, bam, 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 and these ones, the opposite ones, as yellow. So if for some reason the green ball becomes to the right, let's say here comes the green ball, this one, I'll copy green, yeah, it is copied to here. Then look, we can still consider its moment anti-clockwise, like here, but with a negative x. So it is not mg times positive 1 rotating us anti-clockwise, but it is mg times negative 1 the distance. Again, rotating us anti-clockwise, which basically means that it's physically rotating us clockwise, but since we put a negative number, it rotates us anti-clockwise. And so it works just in the same way. So technically we can think of it as one ball standing in the left. So despite it goes over the middle, we can still think of it as the ball technically on one side but with negative x. And obviously if we choose one blue ball and one yellow ball that converge towards the other, like this one for example and this one, then total moment on the right decreases by 1 and total moment in the left also decreases by 1. They decrease by the same amount. If their sum of moments in the previous step was equal, then their sum at the next step, all left part and right part decreased by 1, will also be equal. And so this finishes the proof. And this is a physical proof. And I want you, my friends, my listeners, to think of mathematical tasks as of physical problems. So this finishes everything.